So here's a quick review of trigonometry. Trigonometry is the study of triangles. So we're going to start with basically reviewing the trigonometry in right angle triangles. First thing that we want to remember that angles in any triangle, it's not only in right angle triangle, all angles add up to 180 degrees. So it's whatever the angles inside a triangle, they add up to 180. When you are labeling a triangle, we always label it, the angles are capital letter, right? And then the side that's across from that letter is the smaller letter. So if I have angle A here, right, the one that's opposite to it, the side that's opposite to it will have side A. Okay? Angle C, the side that's opposite to it will be side C, and then angle B, the side that's opposite to it, will be side B. Okay? This is how we label our triangles. In right angle triangles, we name them a little bit differently here. In right angle triangles, we have three names that we always have to use, which are the hypotenuse, the opposite, and the adjacent. Okay? It all depends on which angle is my angle of interest or angle of focus. Okay, so it's the angle that either I'm looking for or the angle that I know. All right? Now, the right angle triangle is never our angle of focus. Okay? So if I have a right angle triangle here, the right angle always going to have the hypotenuse as its opposite. Okay? So the hypotenuse is always going to be, no matter what other angle I'm given, that's going to be your hypotenuse. Are we okay with that? Now, the other two sides, they're going to either be called the opposite or the adjacent, right? And it depends on what angle of interest I have. So let's say if this is my angle of interest, so this is the angle that's given to me or the angle that I need to look for, right? The side that's opposite to it is going to be this side because that's your opposite side. Okay? And the other side right away is called the adjacent. It's the side that is used to form the angle with the hypotenuse. Okay? If my angle of focus changes, and this is my angle of focus, let's say, right? Then where's your opposite? This one. Right? This is your opposite. And then this is your adjacent. Okay? It depends on where is your angle of focus. Okay? We need to be able to label these triangles so we know which trig ratio to use. Okay? Because with right angle triangles, to solve for an angle or to solve for a side, I need to use one of the trig ratios. Do you guys remember this? You remember the trig ratios? So we have the sine, which is opposite over hypotenuse. We have the cosine, which is adjacent over hypotenuse. And then we have the tan, which is opposite over adjacent, using the acronym SOHCAHTOA to remember. Okay? So it depends on what scenario I have, what angle is given to me, what size is given to me. Then I will choose which one of these three ratios to use. All right? Another thing that we can use with right angle triangle other than the primary trig ratios is the Pythagorean theorem. Do you guys remember the Pythagorean theorem? So Pythagorean theorem is used if you are given two sides and you're looking for the third. In a right angle triangle again. So all of these scenarios are in a right angle triangle. Okay? So in this case, what I have is a Pythagorean theorem says that if I add the square of the sides, so if this is called A, B, and C, right? Always the hypotenuse is C. The square of this side A plus the square of side B is going to equal to the square root of side C. So it says that a squared plus b squared is going to equal to c squared. Okay? So in this case, I have to know two sides, and I'm looking for the third. If I know a and b, I plug them in, square, find c by square rooting. Okay? Now, if I know, for example, if I know b and I'm looking for a, what would my formula be? So I'm looking for a. No. In this case, remember, this is my original formula. Okay? So this is the original formula that I'm going to have to derive the other formulas from. So if I'm looking for a squared, I bring the b squared over, right? And that becomes c squared minus b squared. Okay? Remember that c represents the hypotenuse in this case. The hypotenuse is the longest side in the triangle, in the right triangle. And it's always going to be the longest side. Are we okay with that? Now, what if I know A and C and I'm looking for B? So what would the formula be? B squared equal C squared minus A squared. Okay? So these are the three versions of the Pythagorean theorem. Okay? The original one is the one where you add the sides squared, and it's going to equal to your hypotenuse squared. Okay? So let's look at this example. Okay? So this example is giving you a right angle triangle. And you know it's a right angle triangle because it gives you that little square on the side, telling you that's a right angle. What is given to you? So the two sides, right? Yeah. And what is it asking you to look for? The hypotenuse, right? Now, my question to you, does it matter if I call this A and this B or this B, this A? Doesn't matter. A and B don't matter, right? It could be called whatever. The C is what matters, right? The hypotenuse is the only one that's called C, okay? So this is your hypotenuse, which is C, and that's what you're looking for, okay? And then let's call this A and let's call this B, okay? Now, to find C, what formula do I use?
A squared plus B squared.
Yeah. Equals C squared, yeah? So I have to use Pythagorean theorem. I plug in the values for A and B, so that's 60 squared plus 250 squared equal to C squared. So that gives me 66,100 equal to C squared. Am I done? Did I find C? No, I found C squared. How can I find C? Square root. So my C is 257.1 and kilometer. Right? Your answer should make sense. Is 257.1 greater than the other two sides? Yes. Right? And it should be because the hypotenuse is your greatest side. Are we okay with this? So for B, it's asking you to solve for the angle, right? For angles, we usually use Greek letters to indicate the angles. In this case, they use the letter theta. I don't know if you guys recognize these letters, but angle theta is used in this case. So basically, I am looking for that angle, okay? So if I'm looking for an angle, theta, what do I have to do here? It's a right angle triangle, yeah? Okay. So the first thing I need to name my triangle according to my angle of interest. Okay? So which one's my hypotenuse, which one's my opposite, which one's my adjacent? So 14 is what? It's the hypotenuse, yeah? How about the 8 meter? That's your opposite because that's the one that's opposite to your angle of interest. And right away, that will become your adjacent. Okay? Because I'm looking for that angle, right, I have to figure out which trig ratio do I use. What sides are given to me? The hypotenuse and the opposite, right? If I look back at my trig ratios, which one of the trig ratios have the opposite and the hypotenuse? Sine, right? So that means I have to use the sine formula, okay? So it says sine theta equals to the opposite over the hypotenuse. I know the opposite and I know the hypotenuse, so I'm just going to plug the values in. So sine theta equals to 8 over 14. Anytime you're looking for an angle, right, to solve for that angle, you have to do the opposite operation, which is the inverse of sine. Okay? So to solve for theta, I have to do the sine inverse of 8 over 14. So make sure that when you do that, you put the 8 over 14 in bracket. And your angle is going to be to the nearest degree. So usually angles, unless the question say so otherwise, I usually leave it to the nearest degree. So in this case, it's 39 degrees. Okay, so make sure you do sine inverse, open bracket, 8 over 14, close bracket. Did you guys get this? Make sure that your calculator is in the degree mode. It should say D or DG at the top or something like that. Or nothing. Yep. It does say D, right? Right here. So you have to do shift sine and then 8 divided by 14, close bracket. Did I? Oh, you know what? It's not your fault. It's my fault because my calculator is in grad and not in degrees. Yours is fine. It's mine. Yep. So the answer is not 38. It is 35. right? See, like my calculator gave me was not in degree. And I'm telling you, you guys have to be careful that your calculator should be in degrees. All right? Are we good with that? Okay? So the deal is you need to know which formula to use. Okay? You need to know which formula to use so you can, you need to know what you're looking for, how to name the triangle, which formula to use, and how to use it. All right? I'm going to leave you guys to do some